Hey, sixth graders, we are getting started here on lesson 1.2, where we are going to look at some rock samples, make some observations, and study rocks. So our unit question is how rocks form, which is what we are going to be investigating, and then we're going to look at how they can change or transform. And we talked a lot about that in our last lesson when we talked about energy and we talked about matter. And so we're just going to dig a little bit deeper and learn how rocks form and then looking at that transformation process. We are going to be taking on the role of student geologists, and we are going to watch a little video which is going to help introduce that and get us excited about what's to come. So just sit back and watch this video.
And remember, the next time that you look at a valley, just think about how the river cut through the rock layers. All right, for the last bit of class, we're gonna start on our next project. Who remembered to bring their rock samples that they collected during break with them? Wonderful, let's bring them on out.
I'll be glad not to lug this thing around anymore. I just wanted to make sure it was big enough.
I think it's big enough.
Talk to the person next to you and share your observations.
Oh, wow, your rock has a lot of really shiny grains. Mine doesn't have that.
Yeah, I can see that too. You also have a lot of very fine-sized grains. Where'd you find it?
The Great Plains, back home in Nebraska. Here's a picture of the hill where I found it.
Huh. Where's the hill?
That's it, right there.
Huh. Yeah, it's pretty.
Where's your rock from?
Oh, I got it while hiking the Rockies in Colorado. And I found it right about here.
Wow. Okay, now I see why my hill didn't seem so tall to you.
All right, report back. What did your groups discover about their samples?
Some of the rocks are a lighter color while some are dark.
I noticed mine had a lot of light and dark colors in it.
Any ideas why we might be seeing multiple colors in one rock? Yes, Nadir.
Well, rocks are made up of one or more minerals, so multiple colors probably means it's made up of different minerals.
Indeed. Geologists can tell a lot about the formation a rock comes from by finding out what minerals make it up. Yes, Corey.
How can they tell what minerals make it up?
That's a great question, and that's what we're going to investigate in our next project. Everyone bag and label their rocks and put them in that box on their way out. I'm going to analyze each of your samples to get data about their mineral composition. And at the next class, we'll review the data sets and pick a few to investigate further.
Maybe the table.
You're probably right.
I've analyzed your rock samples, and I have them up here for you all to pick up after class. All the rocks were from different locations, but two of them had a surprisingly similar composition of minerals.
Hey, those are ours.
How can they be similar? It looks so different.
Even though these two rocks were from 200 miles apart and from totally different areas, they have almost the same amount and types of minerals. Can anybody tell me how this could be possible?
Maybe after the rock formed, something separated them.
Yes, Corey.
Or maybe the rocks formed separately, and then the minerals from the older rock became a part of the younger rock?
Great idea.
But which one of us is right?
Well, that's for you all to figure out. For your next project, I want all of you to investigate how a formation from the Rocky Mountains and one from the Great Plains can appear so different, but have similar mineral compositions. And I'll be happy to give this back to you, Corey.
All right, so some things that I noted from this video is some of the observations that the students made were that they had shiny grains, there was fine-sized grains, there was lots of colors, and that they think that potentially the colors have to do with some sort of the mineral makeup. So we are going to learn a little bit more about these areas, the Great Plains and the Rocky Mountains, as well as what a hand sample is before we get into our actual observations here in this lesson. So let's look at this map. We learned in our last lesson that the Rocky Mountains fall in this area, And the Great Plains are just to the east of the Rocky Mountains in this area. So we can have some pretty notable differences if we look at the elevation of these two areas. So we learned about the elevation, the high points, those are those dark red places, and the low points are the green places and the yellow places. So we can see some pretty notable difference when we just look at some observations just looking at this map. So we are going to be looking at how the hand samples from the Rocky Mountains and the Great Plains had similar mineral composition, yet as we can see, they come from very different places. So the first thing that we're going to do is we're going to make some comparisons about these by looking at the similarities and the differences. So again, here's an image of the Rocky Mountains and an image of the Great Plains, and we can see some pretty huge differences just by looking at these observations. So we have huge mountains, we have some little rolling hills, we have lots of grass and grain in the Great Plains, and in the mountains we can see we have some sort of trees and then lots of rock here and some snow on the mountains. So the first question in our unit is, how did the rocks of the Great Plains and the Rocky Mountains form? So before we can really learn about these hand samples and what's made up of them, we kind of have to figure out how did they form in and of themselves. So the two claims that we heard at the end of that video, we are going to evaluate in just a moment. So claim number 1, if the rock in the Great Plains and the Rocky Mountains formed as one rock formation, that means they started off as one region of rock that formed together. So one rock that formed together in one place at the same time as a single rock type. So only one rock type. And over some time, something may have separated the region. And claim number 2, if one rock formed before the other, so one rock formed and then another one formed later, and the minerals from the older rock became part of the younger rock, that means that the materials from the rock of the one area transformed into the rock of another area. So when we say transformed, we're talking it transformed or it changed into the rock of another area. So a rock formation itself is, these are some images, but a rock formation is a region of rock that formed together as a single rock type. So all of these rocks form together and they are one type of rock. So they all have the same mineral composition. And if we look at an example like the Grand Canyon, each of the colors or groups and layers that we see in the Grand Canyon is a rock formation. So each of these layers is its own rock formation and it's the same rock type. A sample is a small piece of a single rock formation. So this hand sample right here came from one of these layers of rocks. And again, a sample is just a small part that is meant to show what the whole looks like. So it could be like one little piece of a huge puzzle. And we're going to look at hand samples and analyze hand samples because they're really important to geologists and they help us and they give us information about what type of rock formation the rock came from. And also it can help us better understand the environment that a hand sample came from or a rock came from. And we're going to make observations here in this lesson of 4 different hand samples. And we're going to study them to learn how we can gather more information and gather evidence about these rock formations. So you're going to have 4 hand samples and they just represent different types of rock that are commonly found on Earth. The hand samples help us better understand the minerals that are in a rock formation and also how the rock formation formed in of itself. And remember that different rocks have different amounts and types of minerals, and that helps us better identify the characteristics and what kind of rock it is. So it depends on the minerals that it's made and how it's formed. And we are going to make these observations of these samples here using this very specific guideline. So the first thing we're going to do is we're going to make qualitative and quantitative observations looking at numbers, colors of grains in the rocks. We're going to make observations about the size and the shapes of the grains themselves. So when we look really close in those rocks, those little pieces, those grains, we're going to look to see if they're kind of stuck together or if they're more fitted together like puzzle pieces. We're going to observe the texture of the rock and if it's really hard or maybe if it's really soft. We can also look at that density like we talked about in class yesterday. And we're going to look and see if there's any unusual features in the rock, like bubbles or fossils in any type of rock if we find those things. Remember that hand samples represent different types of rock that are commonly found on Earth, and we are going to consider some different things when we're evaluating these rocks. So we want to think about if the hand sample is hard, so if we can kind of touch it and it's really hard, does that mean that the whole rock formation is hard? Or if the hand sample has rounded edges, does that mean that the whole rock formation has rounded edges? So just thinking about those pieces and putting them together as a whole. For your assignment today, you're going to need 4 different hand samples, a magnifying lens, and then the must-do 1.2 practice assignment. You're going to use the observation guidelines to make and record observations about the hand samples. Take some pictures of your hand samples to upload into your assignment, and then you can work on the should-do assignment. I hope you enjoy checking out the hand samples today, and I look forward to working with you on these. Remember, today is a great day to learn. Happy learning!